Welcome, folks. This is Mr. Bailey here, and this is your first geometry lesson. I'll be directing you through this magical, wonderful world of geometry here. Today we're going to start off with really the building blocks of what we're going to do for the entire semester, actually the entire year in geometry. In 2-1 we're going to talk about points, lines, and planes, and the objective is to understand the basic terms and postulates of geometry. Okay. Terms, as in vocabulary, the definitions, and then postulates. We'll talk more about that a little bit later, but that's really the rules of the game, kind of the rules we're playing by here. Alright, so here we go. Alright, so a few of those terms to start off with: point, line, and plane. Take a second and pause the video. Copy these notes down. You're not going to be able to take them as I'm explaining them here, so we'll give you a second to do that. And so for each of these, we want to talk about the definition, how we name it, and then actually draw a quick diagram of them. Okay, starting off with a point is something in geometry that indicates location. And we're never worried about the size of the point, whether it's big or small, just the location of that point. To the diagram, that's what a point looks like, a little dot. And as far as how to name it, we'll always name a point with a single capital letter. So in this case, I call this point A. We name it just point A. Moving on to lines then, I'm going to say a line is a straight path in two opposite directions, okay, like so. There's no thickness to a line, so again, we're not worried about how fat or skinny the line is, just the direction it's going in. And then also we're going to say that lines in geometry have no end. We'll represent that visually by having arrows at the end of our lines. Okay, so when we draw that, when we think of a line, we're going to imagine it continuing on forever. Obviously, real world, that doesn't happen. But in geometry land, okay, we imagine things continuing. Two ways we can name a line. First is with 2 points on the line. So if points A and B were on this line, we could call this line AB. Notice I have a line symbol above it with arrows on both sides. Okay, or I could say it's line BA. The order doesn't matter when you name a line. Other way I could name this is with a single lowercase letter. Okay, usually geometry books will use cursive letters, italicize them, kind of make them look fancy. Okay, L is a popular one. We'll say that's what a cursive L looks like. So I could also call this lowercase letter L line L. Last thing we're going to talk about quick is a plane. We're going to say a plane is a flat surface. Okay, such as the floor you're standing on, a table, a whiteboard. Again, there's no thickness to a plane. We're not worried about how thick it is. And also, we're going to think of a plane as having no end, just like a line. Okay, so here we have the plane represented with a rectangle. It has kind of borders to it, but we'll think of it extending on. Two ways to name a plane as well. First is with 3 points. So if I have points A, B, C on that plane, I could just call it plane ABC. Order does not matter. We could just as easily say BCA, CAB, BAC. Okay, it doesn't matter what order we go in. The other way we'll name a plane is with a single capital letter. Here I have a P attached to this plane, not attached to a specific point, but to the plane itself. Okay, so we could say this is plane P. Okay, notice as we move up in dimensions from 0 to 1 to 2 dimensional, we have to add a point, okay, to each of the names we have. Points with 1 point, lines with 2 points, planes with 3 points. Okay, so we kind of see these parts building up as we add complexity. Okay, 2 more definitions we'll talk about quick before we kind of check for understanding. Collinear and coplanar points. Anytime you see this co prefix, that means the same or with. Okay, so collinear points are just going to be points on the same line. Coplanar points then will be points on the same plane. Collinear, same line. Coplanar, same plane. Alright, so problem 1, let's check for some understanding on those definitions. Here we have a geometric figure, and if you're having trouble sorting this out, it's a plane kind of slanted towards the screen. Okay, with a line that pops through the middle of it. This dotted line shows that this line hits it in the middle and then goes behind the plane. Okay, and tell you what, why don't you hit pause on the video, try to answer these questions about lines, planes, collinear, and coplanar points, and then hit play to check and make sure you got the right stuff. All right, so part 8 wants to know what are 2 other ways to name line LJ. Okay, now there's only one line in this picture, but if I wanted to figure out which line we're talking about, I'd find point L, I'd find point J. Okay, I draw the line through that. Okay, so line LJ is talking about this line right here. There's a couple ways we can name it. First off, I could just flip the letters. I could say this is line JL. Notice I draw my line symbol above that. Okay, or I could pick a different point on the line to use, such as K. So I could also call this line JK. Okay, we'll say dot, dot, dot. That's 2 ways to name it. There's a bunch of other ways. Basically pick any 2 points on this line and put them in any order. You've got a good name for the line. All right, B, what are 2 other ways to name plane P? All right, so we have this P right here attached to the plane without any other points. We call that plane P. Okay, so we can use a single capital letter, or with the plane we use 3 points on the plane. So for example, I could say D, A, J. Okay, or we can include the B and say BJD. Again, there's other ways to do that. Just pick any 3 points on this plane and put them in any order. Part C asks, what are the names of 3 collinear points? Okay, so in other words, 3 points on the same line. Okay, well there's only one line here, so I'd say that L, J, and K are my 3 collinear points. Put commas between them because we're not labeling plain LJK, we're just saying L and J and K, those points. Okay, last part, D, what are the names of 4 coplanar points? Okay, well it looks like the only 4 points on the same plane would be D, A, J, B. Again, coplanar just means points on the same plane. All right, next set of definitions deals with pieces or parts of lines. Those are going to be segments and rays. I'm going to say a segment is part of a line between 2 endpoints. Okay, so if I have my line in red here, extending on and on in both directions forever, and I put 2 points on it, a segment would be every part of that line between those 2 points. To name a segment, you use 2 endpoints. So if I have points A, B as my endpoints, I could say it's just segment AB. Notice I don't have arrows on top here. That's our segment symbol. Or just like with the line BA, we can switch the order. Okay, a ray then is going to be part of a line from one endpoint on. So in other words, I find an endpoint on that line that extends in both directions, and I just go in one direction or the other, okay, continuing forever, that's going to be a ray. Kind of like a ray of sunshine, it originates, it starts at the sun could be our point, and then it goes on indefinitely in that direction. Okay, so same idea with a ray of sunshine. To name a ray, we use the endpoint and another point. So this ray here, I'll say it's ray BA. I always start with the endpoint, and the ray symbol always goes from left to right, even though that this arrow here is going from right to left. Okay, with a ray, I cannot change up the order here. I cannot say that this is ray AB. Don't do that. Okay, ray AB would be something else. That would be the ray starting at A, running through B in the other direction. Okay, so different ray. One more thing we'll say about rays. We'll talk about something called opposite rays. Those are going to be 2 rays that share an endpoint and form a line. So in other words, if I have 2 rays, ray BA and BC, that start at the same spot, point B, the same endpoint, and go in opposite directions forming a line, I then say that BA and BC are opposite rays. Again, notice both these names start with the endpoint. Both the ray symbols go from left to right. All right, let's do a quick check for understanding on those definitions once again. We have our geometric figure, a few questions about segments and rays. Hit pause on the video, try to answer those questions, and then hit play to check your answer. All right, so A, what are the names of the segments in the figure? Okay, I see a few segments. First off, I see DE, the part of the line between D and E, so we could say DE is a segment. Next segment I see is EF. So we have segment EF. And then last, if we kind of put those two segments together, I get the larger segment, DF. Okay, so 3 different segments. Now there's multiple ways to name them. Instead of DF, I could have said OR FD, just flipping the letters around. But this question isn't asking us to name them in all the different ways. It's just saying name the different segments. Problem B asks, what are the names of the rays in the figure? Okay, bunch of rays. First off, I'm seeing here is DE. Okay, the ray starting at D through E. Now with this particular ray, I could say OR DF, since it's going through F as well. Okay, I can't change the order of those letters for a ray, but if there's more than one point it goes through after the endpoint, there's more than one way we can name it. Okay, looks like I also have EF here. Okay, 2 rays that go in the same direction, but those are different rays. Looks like we also have ED. And then the last ray I see would be ray FD. Again, same direction, just starting at a different point. Last question C asks, which of those rays in part B are opposite rays? Okay, the 2 opposite rays I'm seeing here would be ray EF and ray ED. Okay, opposite because again they share the same endpoint, point E, and then go in opposite directions, forming a line. Okay, last thing we're going to talk about are some of the few basic postulates of geometry. Now when I say postulate, I'm talking about a statement accepted as fact. Okay, something that we don't need to prove is true, we'll just accept it's true. Okay, kind of like it's common sense. Okay, a few examples of postulates. First one says that through any 2 points, there's exactly one line. So if I have 2 points, A and B, there's only a single line, single straight line I can draw through those 2 points. That'd be this line L we have here. Okay, that's why we use 2 points to name the line, because if we have 2 unique points, we'll get a unique line. Second postulate says that 2 lines intersect at exactly 1 point, meaning that if I draw 2 straight lines, line M and L, if they intersect, it'll be at a single point. There'll be one single point in common. Here I have that label as point P. Two more postulates. Third postulate, 2 planes intersect in exactly 1 line. So if I have these 2 planes, green and blue, crossing each other, where they match up, where they meet is going to be along a line. Okay, think of your wall and ceiling coming together. The edge it comes together at is going to be a line, or your floor and wall comes together in a line. And then last postulate, through any 3 non-collinear points, there's exactly 1 plane. Okay, just like we need 2 points to name a line, we need 3 points to name a plane, because 3 points will give us a unique plane. All right, so last check for understanding here on those postulates. Again, geometric figure. Here we have a box, and the edges will represent line segments, corners, points, and the sides of the box, the faces, we can think of as planes. And we have 3 questions for you about intersections of lines and intersections of planes. Again, pause the video, give those a shot, and then hit play to check your answer. All right, A asks, what is the intersection of line AD and CD? Okay, well, let's highlight those first. Line AD here runs to that upper left side of the box, and line CD runs on the top back piece. Okay, we said that 2 lines intersect at a point. The point that those 2 lines come together looks like it's this point D here. So I'd see their intersection is point D. Okay, notice I don't actually need my picture for that. Both names have a D in them. All right, so we could have just stole that from the names. Next question asks, what is the intersection of plane ADC and BFG? Let's figure out where those planes are first. ADC, if we find points AD and C, that's on the top of the box. So it looks like here we're talking about the top plane. And BFG, those are all on the right side. So here we're dealing with the top and the right. Our postulate stated that 2 planes intersect in a line. Okay, so we're talking about the edge where these 2 boxes, sides of the box come together. Okay, that line here would be BC. So we'd say segment BC is the intersection of those planes. All right, problem C asks the opposite question. It says, what are the names of the planes that intersect at BF? Okay, if we find line BF here, we want to figure out what 2 planes come together there. Well, that would be the front of the box. So picking 3 letters from the front, we could say AEB. All right, and the right side of the box again. Picking 2 letters from the right side, we could say BCG.